All right. Hello, everybody. Welcome to everyone who has joined. Hopefully, I have my windows and slides and audio sharing as they should be. Welcome. If you have joined this call, you are here for the Voxel51 webinar on designing data infrastructures for multimodal mobility data sets. My name is Nick Lotz. I am a member of the community team here at Voxel51. We are focused on all things education, enablement, cultivating kind of the ecosystem around how Voxel 51 ultimately integrates and works with the broader computer vision community at large. Just a couple quick piece of housekeeping items. The goal of this webinar is to really kind of talk through a pretty specific and interesting topic end to end, which is working with uh, mobility visual AI applications, specifically from a data-centric AI perspective. What are some of the challenges in this space, particularly in recent weeks and months? If you've been at a conference recently, you've seen some of the exciting things coming down the pike. And then kind of later in this webinar, more specifically, where does FiftyOne work in as kind of a platform layer for managing the end-to-end data curation, training, evaluation, and deployment workflow? Really kind of the big takeaways from this webinar is ultimately for you to become what we might call comfortable and competent working with multimodal mobility data sets, particularly from a scaling perspective. We realize very quickly that that kind of end tail pushing the performance of particularly visual AI models, particularly in time series mobility data, really comes down to managing very large scale data sets and understanding what are the different slices, views, modalities that can result in model failure modes that might not be obvious at first. And then how do we ultimately like push the performance of our applications forward by at first understanding how our data is constructed, and then number two, like being able to build things because we have actual and accurate insight to our data. Couple other bits of housekeeping items. This workshop webinar is being recorded, so you will receive some follow-up materials after this. It'll be a combination of slides and demos by me, particularly towards the tail end of this talk. My goal is, again, to kind of leave you with some takeaway items, resources, ways you can get started and continue to move forward with respect to what we talked about today. Again, from a topic perspective, the focus is largely going to be on mobility data and fleet stream data sets. But ultimately, a lot of what we talk about, I think, are items that are coming to the fold with almost any type of industry vertical, right? Like the problems of multimodal data, of scale, of efficiently training models on massive data sets and understanding like what do we need to optimize in those data sets to push model performance. Those are things that are by no means limited to like AV or mobility data. All right. Towards the end, there will be a Q&A. The goal, again, is to have as much kind of interaction towards the end as possible, such that if any questions come up about what I talked about the 51 platform, about next steps, or just about this topic in general, we can address those. From an interaction standpoint, based off kind of the number of folks here on the call, one thing I would recommend is if you're able, you can interact in one of two ways. The easiest way is that you should find a Q&A panel. If you click more in your Zoom platform, or actually depending on how you've kind of logged in, there might be a couple ways that you'll be able to interact. There's a Q&A panel in Zoom you can use. If you use the chat function too, I'll be monitoring that as well. It can get a little bit busy in that chat function, but I'll do my best to monitor it. But based off kind of the numbers on the call, that'll be easiest. And then once we move into the Q&A, I'll try to open up things a little bit as well if folks are okay with it. All right. Last piece, just a little bit about me. As I said before, my name's Nick. I'm on the community team here at Voxel51. I'm a software developer by engineering and by trade. My original background is very much in kind of the dev infrastructure and tooling ecosystem. Somewhat more recently, have been working in computer vision specifically, but largely my background is in uh, is in system engineering. And ultimately, again, kind of the goal here is to really kind of walk you through what it means to design these sorts of data infrastructures from both a computer vision and system engineering standpoint. Um, so from a background perspective, because I'm starting to see these questions come into chat, I'd say, the goal here is it's meant to be accessible and uh, comprehensible to most folks with any kind of like data science or machine learning technical background. You don't have to be only from the mobility space, but it's certainly helpful. You don't have to be have to have necessarily worked comprehensively or extensively with 51 at this point. Although, again, if you have exposure, it's certainly helpful. Really, the goal is to kind of walk you through much more of a problem solving approach here. All right. Here's the agenda over the next hour, or maybe we'll say 45, 50 minutes, excluding Q&A. Really what we've encountered in the industry is mobility data has sort of broken our traditional, both static and dynamic storage needs when it comes to training models. Mostly because there's so much of it, and it is in constant, what we might call constant time series flux. So it's if you think about maybe traditional like manufacturing data in certain ways, right? That's still time series, but at the same time, it's often a very structured, you have certain sensors that are in a fixed place at a fixed time, that you have overhead angles looking, and it's a very clear what might be like an okay versus not okay product. It's a little bit more binary. With mobility data, and especially real world mobility, you're constantly interacting with dynamic environmental factors that you can't control. So your data set needs to really represent the entire expanse of possible environment interventions that can make it very, very difficult to know, A, is your data set representative of your environment, of the real world? And two, how do we actually know whether once we deploy our models to real world physical AI applications, whether it's actually performing as expected in the real world? Ultimately, where we're going with this is one, a lot of this comes down to proper design. Is your data set properly designed as a core part of your data engineering infrastructure so that it scales? That's a system design problem. That's not just a software problem, and it's not a vendor problem. It's ultimately, are you designing it as a proper system? Number two, though, is we're going to introduce the 51 platform. And I'm going to kind of take two approaches to this. There's a lot you can do with 51 open source. So 51, if you're not familiar, is fundamentally at its core an open source application for managing AI data sets, for building AI applications. There's so much you can do with the core 51 library. I'm going to kind of walk through using that as part of a demo in this talk here in a little bit. And at the same time, there is also, a 51 enterprise version as well that you can try, and then you can ultimately choose to purchase as an organization. I'll be demonstrating that as well, ultimately to just kind of augment some of the demos that I'm doing, mostly again as part of a system engineering discussion to show, hey, what sorts of things are needed once you reach a certain scale. We'll talk about things like data set versioning, proper governance controls, integration with data warehouses and data lakes. And then lastly, kind of integrated with this roadmap, we're going to talk through a few core workflows that are really like the pillars of how, especially multimodal data sets, what's necessary to build and deploy models based off of them. That includes curating data sets that are, again, representative of the actual real world conditions. And then if and when your models do fail for whatever reason, what are the scenarios in which they're failing? And then how do you kind of backtrace that towards the representativeness in your data set? If you have a self-driving car that is like consistently failing in the rain and missing potholes at 2 a.m. in the rain, how do you identify whether your model is being trained on the appropriate data and how your model performs based off the current training set where that particular scenario takes place. And then lastly, governance, right? Mobility is very often a safety critical scenario. More and more, both industries and governments are regulating how those applications are released and conformed in the real world. How can you actually add traceability, access control? Those are kind of table stakes. We won't spend too much time on them, but again, they are critically important from a management standpoint. Okay, so let's start with part one, which I'll call the data mobility challenge. I'm going to spend a few moments that we'll call that on slides that I think frame the conversation in the way that we need. But pretty quickly, I'm going to jump into a demo to at least kind of get us started with when we talk about multimodal data sets. A, what are we talking about? What types of data modalities are represented? And like, what are the initial points of friction that we encounter when working with these in the first place? So again, I think most of this, for those that are in the industry, I hope this is not new information. Ultimately, when you're interacting with any type of mobility data, when it comes to, again, self-driving, robotics, anything that interacts with the physical world is not 2D images. It's incredibly sensory and it's three-dimensional. But it's not only three-dimensional in terms of visual space, it's multidimensional in terms of the types of sensors required to make sense of it. So that includes multiple camera angles. In most applications, it still includes LiDAR. It often includes radar, positioning and geographic coordinates with GPS. And more so, all of that data is time series. So it is constantly in flux. So a very quick challenge you run into is not just getting individual samples of data from all these different modalities, but also aligning them according to a very specific point in time. And then not only aligning them to a very specific point in time, but also as a user, as an engineer, being able to quickly visualize what are all the different sensor snapshots at a point in time and aligning that metadata and making sure it's just easily accessible. It's very much easier said than done. And then on top of that, fleets and data gathering generates terabytes, petabytes of logs and samples daily. And very often that gets sucked into a raw source of data aggregation. It can be a data lake, it can be a data warehouse, it could be object storage buckets, it can be a combination of all of those. And how do we make sense of those? And I think a really important point is how do we take that raw information and associate the proper metadata so that it can become a data set that we can perform operations on using software, because software needs information to operate off of to make sense of what does our data represent. So the big problem is like, how do you query properly across modalities? So like, take this natural language example, and we'll talk more about kind of natural language querying a bit later, but like just take the kind of natural language case of find me pedestrians detected by LiDAR, but missed by my camera in the rain. There's a lot of problems there. First of all, are we able to like actually associate this natural language to individual pieces of data? Second, can we associate the individual modalities to particular points in time? For example, LiDAR detected something at a point in time, but maybe the camera and the models trained maybe on that particular modality, maybe that's missed in a very particular condition in the rain. So think about all the different pieces of metadata that need to be associated with all of that. So there's ultimately a problem here. We call it the swamp effect. And I think there's a little, excuse the kind of the highlighting here on this slide. But traditional data lakes alone often aren't enough. Data lakes are important. That's still like a fundamental way in which you're storing massive amounts of data. But by themselves, there aren't enough. So for example, raw logs aren't the same as curating data. And I think the easiest way to explain why is because raw data is simply just too expansive to be able to train a model off of, especially when it's missing like the correct amount of metadata. So basically, quality is more important than quantity from a visual data perspective, at least still in 2026, we found. If you have petabytes or even terabytes of data, being able to associate the right metadata with all of it is ultimately a fool's errand. It's very difficult to do. What you need to do is you need to take some of that raw data and curate it into a data set that is representative enough so that model performance is continuously improving while still using that repository, the lake of raw data, as a continued way to improve your data set to lead to improved models. That's a very common theme we'll be talking about here. Teams are often siloed, right? If teams are working with independent still copies of data for their individual projects, how do you know and ensure that people are working in coordination so that a common source of truth is what is ultimately, training and deploying your models? Again, classic things like governance, nightmares. How do we ensure that data is appropriately anonymized? Who's accessing what and when? And then I'd say, from an engineer's perspective, most important is, can you trace a model failure back to the specific training data version? Like, this is critical. It's basically like the same thing you encounter in software development. Like, if a deployment fails, or if a model fails in this case, how do we know what caused it? Right? Otherwise, you're just throwing paint at the wall. So here's where I'm going to kind of go into things quickly. And ultimately, the goal here is for us to treat perception data sets as first class um, versioned data sets. And to the question in chat, yes, this is being recorded. And for everyone on this call, you'll be sent a follow-up email after this. That'll include the recording. Um, okay, so A, we need the data set, so we need to curate it. And B, we need to make sure that it's in a way that is like versioned and manageable. So let's initially talk about kind of how this all looks together. So I'm not going to ask you to memorize anything from this call. Everyone's here off their own volition. I'd say from kind of a reference architecture standpoint, here's where the different pieces I'm talking about fit into our overall development cycle. So we're going to talk less about the pure ingestion of data. That's done through fleets, that's done through sensors, that's done through all sorts of automated, and even these days, synthetic data gathering. This, and then the last piece over at the very end, you have data consumers, right? You have ultimately the output model, you have the real world applications, you have the model training pipelines. What fits in the middle here is like, how do we manage all of that data from an infrastructure perspective when it comes to our training loop? So ultimately, we have first the storage layer. That includes, in large part, the ability to store all of the associated metadata in an organized way. The way we here at Voxel51 do things is through object storage of samples and metadata that represents our data set. What we can do is, through a feature I'll talk about a little bit later, is pull in from a raw data lake and then curate our data where the source of truth for that data is ultimately an object storage bucket. Couple good reasons for it. Number one is object storage represents a traditional file structure and path structure much better than a traditional data lake. Number two is it's very easy to organize data and metadata in that structure through consistent metadata labels, file names, and so on. And number three is it's very protocol compatible with other pieces of software, right? The S3 protocol is kind of a universal storage protocol. When we then actually use the FiftyOne application, we are loading in a data set whose source of truth is the object storage, but ultimately can be pulling in raw data from a data lake. And that becomes our place to manage everything from curation, visualization, embeddings computation, model evaluation and analysis, um, uh, data set versioning, data set sharing, cloning, version management, which like I mentioned, and so forth. And then that becomes kind of the source control management system through which we can go through labeling workflows, model training and evaluation, which I briefly mentioned earlier. If you're working with like simulation, which I'll talk about later, and even synthetic data, the management of that at scale, that can happen in the compute layer as well, which FiftyOne can connect to. But think of FiftyOne kind of as the source code management system for all of that. Okay. So real quick, before I move into what's next, I think what I want to do is I want to just give you a quick peek at like what is FiftyOne. For those that are new and for those who maybe haven't used it as much, I'll just take a minute or two and just kind of briefly mention it first that if you want to get started with FiftyOne, think of FiftyOne kind of like as Visual Studio Code for managing multimodal data sets. That's a really good way to think of it. FiftyOne is, at its core, it can be an open source application. It is an open source application that you can install as a Python library. It also includes there's also 51 Enterprise, which is, the paid version that includes some extra bells and whistles that gets installed in your corporate environment. So a couple ways you can get started if you just want to kind of put some sense to things and maybe start exploring around. Number one is if you want to install the Python library, you can quite simply pip install 51. So if I share my terminal here, right? It's already installed, right? So, but ultimately, it's a Python library that you can easily install. And then if you're ready to get started with working with 51, you can run import 51 as FO. It's just a Python library. And then you can start using sorry, let me go to the other part of my terminal here, you can start using the SDK directly within Python as Python scripts, as Python methods. It's a fully documented API. You can learn more at docs.voxel51.com. But just to show you a very, very quick example, there's a quick thing I can run here where I can say maybe import 51 as FO. There's a couple sub libraries I'm going to import here. So 51.zoo gives us access to what's called the dataset and model zoo, which is a convenient way to be able to import a bunch of public datasets and models. Import 51 brain is fob. And then I'm going to import a dataset that's from our dataset zoo. We're working with mobility datasets. So we have a public dataset called Quick Start Groups, which is a multimodal group dataset, which is really easy to kind of get started and start visualizing things. So I'm going to say ds for dataset equals FOZ 51 zoo dot load zoo dataset quick start dash groups. And it happens to be already downloaded on my system. It's about a 4 GB data set, but you'll just see a progress bar. It downloads to your local 51 directory or whatever the environmental variable is set on your local system in terms of where you'd store data sets. But by default, it's going to be in, let me actually show you. By default, things are going to go into here. Actually, sorry. They'll go into here. They'll go into dedicated directories. And this is the quick start groups data set. And here's ultimately where all the data set data and metadata is. And then now that I've loaded the data set, if I want to launch the local web server, I can then run something like session equals ds dot launch, sorry, fo dot launch app ds for data set. And then if I jump back to my web browser, I'm running just the local server on my laptop of the 51 application. And there's a whole lot of things you can do here. So again, this is just free. This is just the free and open source version of 51. It runs on the MIT license. It runs on virtual all Linux, Mac platforms, Windows. There's a little bit of intricacies on Windows. I think it runs okay under WSL. I'd have to go back and look at the docs, but definitely every major Linux and Mac platform it runs on. Again, it's just a Python package. And ultimately, we can see here the data set represented. Because this is a grouped data set, there are multiple modalities per sample. So right here, I'm seeing a particular view of a particular sample, but ultimately this particular data set, which is a subset of the KITTI self-driving data set, just a small subset of it, there's a left camera, a right camera, and then a point cloud distribution. So these are the point clouds, left view, right view, and if I click into a particular sample, I can see everything aligned here. Again, here we can see the different views. I can, if it'll let me, oh, I think I just timed out a little bit here. There we go. If I can zoom in, see the any applied ground truth labels, all kind of aligned within the multiple modalities. We can see the label metadata is here for the ground truth. I haven't trained a model on this data set yet because I just downloaded it. But from just purely from a visualization standpoint, you can start to get alignment on all of your samples. Now, again, these are ultimately stored as files on my local file system, but purely just from kind of a getting started standpoint, okay, I can start to see alignment here. I can use this sidebar to navigate through different primitives. I can select samples. Notice these are selectable. I can create new views. If I were to filter things through this left sidebar, I can get additional views as well. So open source 51 is a Python library. It runs locally. Whole lot you can do with it. I'll talk about like embeddings computation in a little bit as well and model evaluation that can really get you started working with data sets. And then 51 Enterprise includes some kind of scalable items that I'll talk about in a little bit also. But again, if you just want to get started, pip install 51 is the way to get started. And then I'll add again, in the example I used here, the software is open source and then the data set is static. Like it's just pulling a static data set from our model zoo, or sorry, from our data set zoo. That's just, it's fixed in terms of its sample content, is in terms of this example. When it comes to dynamic data sets, I'll talk more about that in just a little bit. But yes, this is all stored in my local file system for the moment. All right. Okay, so local open source 51 is kind of one person, one single account, one local environment. Where things start to scale up is when you need an enterprise scale deployment, when you're working in a large organization with multiple people working on multiple projects. 51 will exist there as a scaled out deployment that attaches to a couple different places. So on the storage side, instead of attaching to your local system or your local file system, it instead attaches to object storage. So over here on the left-hand side, I have the same UI brought up, but this is actually the 51 Enterprise deployment instead of 51 open source. And a couple immediate differences we see is number one, I like a little user avatar here because it's now a multi-user system instead of a single user system. In addition, something I'll notice is that when I click on a sample and I look at the sample metadata, instead of a local file system path, this is instead an object storage path. So this source of truth for this data set is in Google Cloud Storage. And this is the object storage path to this, sample. And then the metadata and labels are stored here as well. And that's where the static data is stored. What we could also do is from a storage perspective, we can also integrate with a data lake. So where that becomes a source of data that you can query and augment your data set. So from a data lake integration side, there's a feature called Data Lens that allows you to connect to a data lake that you specify. So we include first-class connectivity to Databricks, to BigQuery, but ultimately it's a Python integration that allows you to kind of specify whatever query parameters you like. So in the case of Databricks, we have it connected to Databricks' natural language search through its vector search integration. And I might say something like people walking in the rain. And I might query my data lake for samples that match that natural language search. And that allows me, if I want, to import additional samples into my core curated data set from our raw data lake in order to augment it in some way, because maybe that's an edge case that I don't have good representation of. So we'll give this just a second to load. And we can see here that these are samples not from my current canonical data set here, but this is querying my data lake that shows samples of that it thinks are people walking in the rain. And then I can choose to select some of these and then import the data into my data set if I wanted to. So from an architecture standpoint, there's that layer, the storage layer. From the compute layer, there are all sorts of operations, even aside from model training, that compute becomes increasingly critical for. So when it just comes to understanding your data, one item that is critical especially in multimodal data sets, are the embedding space. Not just in multimodal data sets, but any type of visual data. Computing embeddings and being able to visualize embeddings gives you basically a numeric, a quantifiable way of understanding your data set distributions, similarities, differences. It's a numerical way to assign value and an additional metadata to each sample in the data set. So when it comes to computing things like embeddings, that almost always requires things like attached compute of some kind. And you can compute embeddings in open source 51. So if I pull up my terminal here, give me one moment, and I'm going to cheat a little bit because I always a little bit blank on the exact command syntax. So I'm pasting from my notes here. I already have my data set loaded. What I'm going to do is I am going to specify one particular slice of the data. So remember we had left PCD right is our available views in our data set. So I'm going to select the left camera view and just save that. Sorry, DS, not data set. So I'm saving the left view here. And then what I'm going to do is I'm going to then use a model to compute embeddings on that view. Similar to how 51 has a data set zoo, 51 also has a model zoo. I'll kind of show you where to find that information on the 51 docs here a little bit later in the call. But if I create a variable called model, and I'm going to load the clip model, OpenAI clip, which we also make it easily callable using the zoo method. So I have that loaded. And now, finally, I am going to use the compute embeddings method. Not finally, second to last step. I'm going to use the compute embeddings method using the clip model I just downloaded, and I'm going to save it in a field that I'll call embeddings left. And again, this is a relatively small data set, so this will only take a moment. And then finally, so now the embeddings, like raw embeddings computation is there. And then finally, I'm going to run a method called compute visualization. That again is just a native 51 method on the left view using my embeddings field. This is using a tool, a sub-library called 51 Brain that includes a lot of these types of algorithms for things like embeddings computation, like F1 score generation, and so forth. And then now the embeddings computation is complete. And then finally, if I relaunch my session and I go back to my web browser here, let me go ahead and go to embeddings. Here we have the lassoable embedding space for this particular view. So this is the left-hand view here. Couple things we can notice. Number one is there's definitely outliers. So if I look at my data set here and I lasso this left-hand portion, we can kind of see is like, oh, this looks different. There's this view is like facing not the road, but facing like a building and a sidewalk and a wall here. So this is, definitely not an edge case, but something that is very visible here. And if I reset my view, I didn't do quite enough steps here to include, and we only have the ground truth labels. But if I were to, fortunately, I didn't do that here. If I were to include like the ground truth labels, I could also color code by the different labels represented as well, like car, cyclist, miscellaneous, pedestrian, and so forth. But these are ultimately, again, persistently stored as a field here. Yes. So answering a couple questions. I'm going to work backwards here. Yes. Torch is assumed to be installed. It is a dependency. If you try to run the embeddings computation, it'll prompt you. It'll basically say, hey, you need to pip install Torch Vision if you haven't. Um, Manikanta, sorry if I mispronounced your name there. Yeah, so from the basic standpoint, there's actually not that much that I did. if you're trying to like follow in real time, um, let me quickly post a docs page here. All I really did was pip installed 51, pip installed Torch Vision, because you need to do that. And then the docs page that I just showed is from a different data set, but it kind of walks through some of what that embeddings computation is. But ultimately, it was just pip install 51, loaded the zoo data set, and then ran a couple methods to install embeddings. What I can potentially do as well is what I'll do is I'll try to follow up with maybe kind of a brief script. That's what I did in the follow-up email if I can. But ultimately, kind of the goal of this year is to, again, just kind of show, okay, you can generate and see this embeddings distribution. Well, last question. I think this is one a little bit further up. This is a good question from Gema. What happens if, or Gemma, sorry, what happens if tow vehicles are using 51 and both are moving um, along a road from opposite sides? When they are in front of the other, can 51 avoid mixing the data? Yeah, so I think this is answering a question. This is asking a question that 51 does not inherently answer. Ultimately, that's a method of how your data lake handles time series metadata, right? So ultimately, 51 does not on its own perform like dynamic data resolution outside your ability to apply the metadata, right? It works with the existing data set and metadata, but it is not inherently generating that metadata and doing the resolution on its own insofar that it can like automatically perform time series resolution outside the metadata already existing. So here we're assuming, okay, there's different tow vehicles, different cameras on each vehicle, right? And ultimately, like that'll be different views of the road, but those will really be different samples in like different parts. They could be part of the same group data set, but they're ultimately going to be different samples in that data set with different views. All right. Okay. So a couple things I want to note here. And a couple of these were brought up as questions already as well. So how do you plan for change? Right. So this part's kind of critical, and this is something that's kind of been implicitly brought up in these questions already. Number one is basically what happens is your schemas change over time. That's kind of one critical aspect. Couple ways you could go about this. Ultimately, what it comes down to, I would argue, is data set version control, which ultimately results in schema version control. So as new sensors and new label schemas come in, how do you like adjust that ontology without entirely breaking your training pipeline and also being able to roll back as needed? Um, that ultimately becomes to like a version control problem in your pipeline. So imagine you have like schema version 1 and you have a pipeline, but ultimately like different sensors change and then labels update. How do you adjust that update? One way you can do so is when you have data grouped with metadata in a consistent way, you can perform version control on that entire data set. So for example, in 51 Enterprise, if I go to sorry, this is not an open source 51, unfortunately, but in Enterprise 51, let's say that let's say I haven't imported data yet. So, right, so my current data set is currently 10,050 samples. What I can do is I could clone the data set, but what I could also do is I can go to dataset history, make a new snapshot of the data set, call it, pre-augment, January 13th, for example. And this just uses DCS under the hood. Save a new snapshot, which will take a second. I have an existing snapshot, so I could potentially use that instead if this takes too long. But yep, there we go. Looks like 3 samples were updated between this one and the last one. And then that's now like, it's basically a Git history equivalent here. And now if I were to like make a change, so for example, people in the rain at night, And again, part of this is a little bit of dead time as this loads, but you saw what I did before here. I might um, import some data. And I might say, hey, I'm going to keep it easy just for the sake of time and compute power and say, I want to import 10 samples. I want to import the data. This is a good case of how 51 attaches to compute. So for any type of compute operation you do in 51 Enterprise, it's not going to be like running on a local laptop, right? 51 actually, fun fact, runs in a Kubernetes cluster if you were deploying it at enterprise scale. And it attaches to GPU clusters through what we call delegated orchestrators. And then we can run as an operation on an attached cluster. Now we have an import scheduled. And it's queued to run here in a second. Depending on the current activity on the system, it might take a minute, but looks like it's currently running. And then once it completes, we'll now have 10 more samples in our data set. But our previous snapshot version it still exists, right? It's an immutable snapshot. So if for whatever reason, if I need to roll back to it, so for example, if I want to browse into this particular snapshot, I have this snapshot. I can choose to share this particular snapshot with someone in my organization. I can work with it just like it's its own data set. Alternatively, I could always go back and view the latest version, but also importantly, I can also choose to do a rollback to the snapshot as well. This is equivalent to like a data set git revert. So again, we have this kind of built-in versioning in place. Did this run complete yet? Nah, it's still, oh, nope, it's completed. And now sometimes from a caching standpoint, this takes a little bit of time to update. Should see 10,060 soon, but I'll let it go. Sometimes it takes a little bit for this part to update. I won't worry about it. Okay, talked about versioning. Again, you can perform tags and views. I won't spend too much time on that here, but again, you can create different views of the data such for example, working through these different sample metadata, you could say, hey, these are a view of like rainy, snowy, or traffic with traffic signs again. And then if you want, you could actually create a clone of that view as well, which is super cool. Um, and that creates a new data set based off that particular sample set. Okay, so I was kind of working in some of 51 open source and enterprise here. I think the one piece that we're now missing is we've talked a little bit about the data curation side. I think we talked about pulling in data from different sources. On open source 51, it's stored in your local file system, and 51 enterprise, it's stored in object storage. Data curation, again, is making your data representative and also just understanding what's in your data set and making it queryable. I think the last piece that is going to be critical here is understanding the relationship of model performance and your data set. So again, purely from a curation side, we already have unified visualization. 51 supports. I didn't actually specifically pull up a video data set, but there's actually a data set we have in our data set zoo called Quick Start Video. You can choose to pull down and work with if you'd like. We already showed you there's 3D point clouds, um, multiple modalities supported. We do also support geospatial as well, if you're interested. And again, we can associate time series metadata also. Another critical piece is governance and security. Before I actually talk about that last piece, though, I do want to talk about kind of the model evaluation side of things. So when it comes to evaluating models, that's another compute intensive activity, right? So the kind of one computation I did was just computing the embedding space. Another computation that 51 can do through an attached orchestrator is model evaluation. So quick note, the actual act of training your model normally occurs using integrated software that's not like the native 51 library itself. Like in 51 as a tool is not inherently a model trainer. You would use existing, model train, PyTorch, other pieces of software to work with the 51 data sets, but ultimately train off that data and labels. 51 includes built-in methods for training models, but it requires like some of those additional pieces like PyTorch or other model training tools. It is not itself like, a native model builder uh, in the strict sense. At the same time, once you do have a model trained, there are a bunch of built-in methods for evaluating models with respect to each other and with respect to ground truth. Within open source 51, it's done through an evaluation method, an evaluate model method, very similar to how I did embeddings computation. Within the 51 enterprise application, there is a built-in um, panel that allows you within the UI to perform model evaluation with respect to different fields. So basically, when you're performing model evaluation in 51, what you're fundamentally doing is you're comparing different fields, right? You're comparing the labels generated by your model with the labels generated by another model or with labels that are your ground truth labels, right? If we're talking about like fundamental kind of model comparison here. So for example, if I were to say, hey, I have these new predictions that were generated with, YOLO-World, basically a vision language a general foundation vision language model, I might compare that to my ground truth detections. And this would take a little bit of time, but execute that evaluation on a local orchestrator. I have a couple of these valuations already. For example, I have this YOLO eval that I've done. It did not do a super good job, but ultimately we can see some of the core metrics, and this is with respect to ground truth. So this is model evaluation with respect to ground truth. Um, so we can see the average confidence, intersection over union, precision, recall, F1, which is fairly low because it's just the harmonic mean of precision and recall. We can see the classes that the model was trained on. So in just this case, car, person, and traffic light, their precision per class. We can see confusion matrices, basically where was their class confusion, both respect to the ground truth and with respect to themselves. And then we can also, give me a second here. We can also compare, give me one second here, models with each other and compare them side by side. And then also what's nice is because we already have this like visual tile, if I wanted to know like areas of confusion, for example, I can click, this is not, again, I'm kind of running out of screen real estate here, but I could click on like a specific like cell in the confusion matrix. Oh, sorry, that's not class confusion. Let's see. And maybe see where there's some like class confusion, like false positive, false negatives, totally missed samples, and so on. All right. Yeah, in terms of um, model post-processing, great question. Um, so a lot of it has to do with like metadata adjustment, which you can. So there's a piece of like actually creating the metadata, which can be done through like the 51 API. So ultimately the answer is yes. You can configure model post processing in 51. A lot of that needs to be done with the 51 SDK. Kind of related to that, if you're specifically working with foundation models and you're specifically working with using models to generate labels, you can perform some of that. I didn't really talk about this feature, but you can perform some of that post processing with the auto labeling feature. So if you're using specifically things like foundation models to generate labels versus like your final deployed application, within auto labeling, you can do things like, sorry, let me look at a couple of these. Oh, I think some of these timed out, but there's like a dragger in which you can like set minimum confidence threshold and like what the label field is and some things like that. But there's a whole lot more that you can do with the SDK, even if it isn't immediately surfaceable in the UI. All right. So from the model evaluation side, again, we really take a data-centric AI perspective to these things in the sense that the most common way that model performance can be improved is not so much through tweaking the model algorithm, but ultimately tweaking the data and finding the failure modes in the data that results in different areas of model performance. And it's a matter of kind of finding and slicing what views result in what model metrics. And if we find certain failure modes, okay, we might need better representativeness. And then we also might need to kind of tweak the model architecture as well. Okay, give me 1 second here. Couple final things that I want to mention here is from the governance and stability side. This is much more on the governance and admin layer. But aside from versioning, aside from sharing and cloning data sets, there is a pretty robust like role-based access control you can do. So for example, if I want to go to my settings here and I want to kind of configure the different roles that are supported, or rather, sorry, if I want to configure the different groups that are supported, I can create different sets of groups, who has access to what, and then in my data set, when I manage that data set, I can configure access based off different groups of people with a particular role and a particular permission. So purely from a governance standpoint, that's something you can definitely do within 51 Enterprise. All right. Okay. Very last piece, and then we'll jump into Q&A, is from an operational workflow perspective. I showed you model evaluation, couple other things that you'll find useful, and these can all be done in 51 open source as well, is using the embedding space that allows us to perform things like visual similarity search. So when you have tags and labels and you've been able to generate embeddings, what you can also do is you can compute what's called a similarity index. And then let's see if I have it. I might not have it on this particular data set, but then I can do things like, yeah, because I already have the embedding space, I can do things like sort by similarity to the query rainy samples. And I'm just realizing now that this might be going on the 10,000 uh, sample data set. So, or it might be on actually the 25 sample piece. But yep, here we can see, rainy samples sorted by natural language, which just purely from a management standpoint, it becomes easier to just very quickly pull out samples according to natural language from our data set. Um, Again, you can perform tagging, you can perform text to image videos. That is actually another piece that I didn't directly mention. We have integration with services like uh, 12 Labs and NVIDIA Cosmos, which makes it easy to start do these similar things with video as well. Sorry, I don't have a direct demo on that piece. But ultimately, the goal here again is just kind of a continuous cycle, right? There's the reason I use the term 51 as kind of almost a VS Code layer for your data set, because it allows kind of a pane for you to ingest your raw data into a curated data set, organize so only the highest value data needs to be annotated and ultimately trained on. That's a resource saver in the long run. And then again, model predictions can be fed back into our evaluation loop to figure out, okay, where are our failure modes? And then you can again continuously repeat the loop. All right. One final piece, and then we'll go straight into Q&A, is if you're very specifically in the physical AI space, which I imagine a lot of people are on this call, we've released a new feature called our Physical AI Workbench, which I will link here. I think is more easily showed here as well, and I'll put this in chat, which directly integrates with um, NVIDIA's tools like um, Cosmos and neural reconstruction capabilities. So the idea here is when you're working with synthetic data, this provides a mechanism to ensure that your data you're using for neural reconstruction is high quality and can easily be versioned and can ultimately ensure that like your data set is ready for full simulation. All right. So key takeaways as we go into the Q&A, because again, I am clock watching over here a little bit. Um, Really the goal here is I found from a standardization perspective, the more you can standardize your platform such that it integrates with the right tooling, so scale is built in and not something you have to think about later, like the higher performing models you'll ultimately get, right? So the integration of 51 to your data lake and data warehouse, to object storage as your source of truth for where your data sets live, the built-in governance, but also just the native capabilities that ultimately originate in the open source Python library from the standpoint of 51 Brains computation capabilities, the model zoo, the dataset zoo, the label schema customization you can do within 51, the custom scripts you can do because it's an open Python library that'll ultimately allow you to iterate much faster. And again, right, the goal here is to just continue the velocity of being able to make incremental model improvements over time. All right. And that occurs with any type of data set, whether it's mobility data sets or any other industry. So from a wrapping up standpoint, I kind of integrated the demo pretty much through all of this talk because I think that ended up making quite a bit more sense. Couple things I want to leave you with. Number one is if you just want to get started with 51, couple things I highly recommend. Number one is go straight to docs.voxel51.com and look at our getting started guides. So depending on what your use case is, every getting started guide is pretty self-contained and it starts kind of at the very beginning, like, hey, pip install 51 is a starting point. So if you're in the self-driving space, if you go to docs.voxel51.com and go to our self-driving guide, you'll immediately be kind of jumping into this getting started workflow. There's an attached Jupyter notebook if you're interested once you get started. And again, it really starts you at the beginning. Piece number two is we have an extremely active community. If you go to voxel51.com/community, that will link you to our upcoming events. That'll link you to where you can find us on Discord if you want to ask questions that way. More async, and we're constantly on Discord interacting with the community as well. And again, we have all sorts of upcoming events in the meantime, if you're just kind of getting your toes wet and looking to explore more about 51. And again, so someone just linked GitHub there as well. That's where you can find like the raw code download instructions. If you want to kind of contribute to the project, that would be awesome. We could always use some more contributors as well. But that being said, I'll stop yapping here for a moment. Let me see if there's any questions I haven't yet addressed. I think there's a few in chat and maybe one in the Q&A as well. So I'll attack the Q&A one first, super quick, just because I think that there's one there. So this is from Joe. When working with large multimodal data sets, is there a performance disadvantage if the data is processed off device rather on device? So does cloud or remote processing introduce significant latency? Yeah, great question. So this is ultimately a scaling question, right? So depending on the size of your data set and the amount of processing you're doing, ultimately, like we found that for data sets that are large enough, you have to use some type of attached GPU uh, like GPU cluster or GPU infrastructure. So it almost becomes moot in the sense that having both your data and your attached GPU on like a laptop or just some kind of compute infrastructure or a server, like ultimately you need some kind of scaled out infrastructure so things like multi-threading and multi-GPU approaches can work properly. Generally, we found that that performance improvement outweighs any latency issues. Um, at the same time, there is a case to be made that we found that for certain folks, having like low latency connectivity between like an on-prem object store and on-prem attached GPUs can be somewhat of a performance improvement as well. I don't have the exact numbers, but the answer is sometimes, and it's ultimately a balance between where, like, how much infrastructure do you need to perform computation, and therefore what is practical versus like how big is your data set, and is it even practical to do it like on device in the first place? Um, so yeah, hopefully that somewhat answers the question. Feel free to rephrase it and do a follow up if I was kind of dancing around what you were actually asking. Um, Can you configure the max temperature? Yes, I just didn't directly show that. I assume you're talking about like model training and evaluation. The answer is yes. It's I just didn't show that as in the UI, but it's a method that is part of the SDK. Um, can we have can we have custom metrics and dashboards for KPIs? Yes. This is part of the open source as well. So hopefully I still have this running. So there is you can using the uh sorry, let me go back here. I think I need to actually import the dashboard, import some additional things for dashboards. This is possible in open source, but yes, there are custom dashboards you can create. There are custom model value metrics you could create that shows up in that model evaluation pane. Precision recall F1 are what comes out of the box, but you can configure your own as well. That's just isn't done through the UI, it's done through the SDK. Let's see. Do you need to have an account in Google Cloud or AWS? No. So 51 open source is just open source. It runs locally, so it just runs wherever you run the Python interpreter, ultimately on Linux or Mac. For 51 Enterprise, it is however you want a deployment in deployed in your organization. It runs in a Kubernetes cluster or using Docker Compose. For the compute, you would need some attached GPUs for computation and delegated operations. But it's not software as a service in the strict sense where, hey, you need to you must have an existing Google or AWS account. It can run on any cloud in any on-prem environment. It's ultimately like, what makes sense in terms of your organization's infrastructure. All right. All right, folks. Well, again, thank you so much for your attendance and participation. There were some great questions. Again, you will receive some follow-up material on this. It'll include a link to the recording. It'll include some additional links to resources and events. Again, I highly recommend those getting started guides on the 51 docs. Everything I did around like pip install 51 and things I was typing on the terminal, that'll all be there. They'll be kind of sandboxed inside each of those getting started guides. So if you're starting from the very beginning and just want to like get the software installed for the first time, it'll take you right from the beginning and it won't assume you have any kind of dependencies installed before you can get going. That's so yeah. Thank you again for your participation. Enjoy the rest of your Tuesday, and I'll go ahead and close things out from here. Thanks again, all.